Welcome back, class. Now, we're going to look at graphing trig functions. Now, what I'm going to do today is I'm going to focus on some essential vocabulary. This is some new vocabulary you need to have down, you need to understand by the end of the period, at the end of the lesson. Amplitude, period, phase shift, initial interval, and midline. These are all related to graphing trig functions. So what we're going to do today is we're going to talk about what each of these are and how you find each of these. We'll also talk about the effects that they have. We'll actually start graphing in the next lesson. Right now, we're just getting the fundamentals down. We're understanding what these vocabulary words are and how they affect the curve. And how do you find amplitude? How do you find the period, the phase shift, and so forth? All right, so what you have here is, this is a typical sine curve. So we start at 0, and we move up. At pi over 2, we reach a maximum altitude of 3. Coming back down, we hit 0 at pi again. At pi, we hit 0. And then we reach a minimum. At 3 pi over 2, we reach a minimum of -3. Now, if you recall from the last lesson, as you move around the unit circle, these values, these y values, correspond to points on the unit circle. But if you remember from that lesson, when you're moving around the unit circle, the maximum value of sine is 1. That is the maximum value of sine. Let me bring that up for you again. So if we look at, let me share the screen real quick here. Okay, I'm going to share my screen with you. And let's just make this a little bit easier to look at. As I rotate around the unit circle, these y values correspond to y values along the curve. Now, because this is going all the way to 100, we have to just pretend this has a maximum value of 1. At pi over 2, the sine is 1 at pi over 2. In this case, it's getting much larger because of this number here. This number here at 100, as I change and reduce that, I can go all the way down, well, this one all the way down to 20. But in reality, I should be able to go down to 0. It's amplitude. This number in front of the trig function is the amplitude. So what that does is that tells you how high and how low you're going along the curve. So as I move around the circle, the curve is moving and plotting points. Okay. So that's what amplitude is. The amplitude tells us how high and how low the curve is going to go. Okay, so what are our maximum and minimum altitudes? Not from 0, but generally from the midline. It all depends on what's going on. Right there, you can see from this curve is oscillating. That's another word, oscillating, meaning it's going back and forth, up and down, it keeps repeating. It's oscillating about the x-axis. The reason why is, in this case, the x-axis is our midline. Okay, so the midline is where everything's going to start, and it's going to go up to a maximum of 3, down to a minimum of -3, because that is our amplitude. Our amplitude for this particular problem is 3. So it tells me go up to a maximum of 3, go down to a minimum of -3 every single time. You can see these values, -3 to a maximum of +3, to a minimum of -3, back to 3, back to -3, and so forth. Okay. So our amplitude tells how far above and below the curve moves about the midline. Okay. So my amplitude is 3. I went all the way up to 3 and I went down to -3. If my amplitude was 4, instead of stopping at 3, I'd go up to +4 and down to -4. And I can show you that real quick right here. Okay, I'm going to share another screen with you real quick. So I'm on Desmos now. And here's a sine curve. You can see my sine curve right now. Starts at 0, 0. It reaches its maximum at pi/2. It reaches 1. At pi, it's 0. 3 pi/2, it hits -1. 2 pi, it's back to 0. Then 5 pi/2, and so forth. Here's another point right there. All right, so that is the standard sine curve. It has an amplitude of 1. This is y equals sine x. Amplitude of 1, because a, the number in front of the sine curve, is 1. Now, if the number in front of the sine curve is different, then our amplitude is going to change. So let's say, I'm going to use this little slider here. I take, instead of a being 1, I move it up to 2. Now you can see my sine curve goes all the way up to 2. So labeling these points real quick. You can see instead of going up to pi/2, 1, it went all the way up to pi/2, 2. And then these points, the zeros are the same. Those don't change. Okay. The only thing that's going to change is the altitudes, the maximum and minimums. That's going to take the curve with it. So I can keep going up. I can go all the way up. Let's go to 3. All right. I can go back down to, let's say, a half. If I go to a half, now the curve is, oh, that's a -1/2. Not yet, not ready for that yet. Here's -1/2. So now it goes up to half as high, see? Pi/2 to 1/2, instead of going all the way up to 1. So the a, the number in front of the sine curve, tells you how high and how low that curve is going to go. Now, if a is negative, watch what happens. If a is negative, what normally happens when there's a negative in front of the trig, in front of any function? It flips upside down. So you can see now when there's a negative in front, it flips upside down. So when you graph, instead of starting at 0 and going up to the maximum first, if there's a negative in front of the sine curve, you start at 0 and you go down to the minimum first. And then you continue on with that curve. You just have to remember how that wave looks. If I go further, goes down to maybe -3. Now it's going to drop all the way down to -3 first. See, at pi/2 hits -3 instead of hitting 1 like it should. Leading coefficient is negative, so it goes down first, and it's going to reach a minimum of -3. So playing with a, you can see what that does is that changes how high and how low that curve goes. Okay, and if any of you are taking physics or have taken physics, you'll know this affects certain things. There are certain curves for sound waves and light waves, and these amplitudes change. They vary, and they make things happen to those curves. These points, by the way, in physics that aren't moving, those are called nodes. Those nodes, they don't move. They'll never change. The amplitude is what's changing, up and down. All right. Okay. Let's go back for a second. So that's amplitude. Period. The period. The period, we're associating that with length, or it could be thought of as time as well. The period is basically how long does it take for the curve to do one complete cycle. That's what the period is. How long does it take to do one complete cycle? Now, what do I mean by that? One complete cycle. All right, let me grab a highlighter here. Now, if I start graphing sine at 0, I go up to the maximum first, back down to 0, down to the minimum, and there. That is one complete period. How do you know it's one complete period? Because now the curve starts to repeat. Once you hit this point, see, what am I doing? I'm going at 0. I start by going up to the maximum first. Once I hit 2 pi, now I'm at 0 and I go up to the maximum. So again, it's starting to repeat and the cycle is starting all over again. So the period is how long does it take for this to happen? How long does it take to do one complete cycle? Well, again, let's go look back at our computer screens, or my computer screen. If I'm looking back here, look at the sine curve. How long does it take to do one complete cycle? So let's see. I can't really stop at 0. This starts at 0. And then remember, as I go up, as I go around the circle, I start moving up to the maximum, back to 0, and so forth. So when does it start to repeat? Now, boom, starts to repeat. How long does that take? It takes one complete cycle around the circle. So the period is 2 pi. All right, that is the period. Okay, so let's take a look now at, I gotta stop this for a second. Now we're coming back. Here we are back at Desmos. And now, if you notice, the equation over here changed. Now I'm looking at b, the number in front of x. b is responsible for the period. All right? So b is responsible for the period. So here's the same thing. Start at 0, pi over 2, we reach a maximum of 1. There's pi is 0, 3 pi over 2, -1, and so forth. That right there is one full cycle. That's one full period right there. One period. Now, think about what happens in parentheses. Whenever we graph functions in the past, if something on the function, if in the parentheses it says x minus 2, what do? We go right 2. If it says plus 5, we go left 5. Whatever's in parentheses, we always do the opposite of what it says. So let's say b, and for the number in front of x is a 2. That's 2 times x. Well, 2 times x. What's the opposite of multiplication? Division. So here, the period is 2 pi. The period right now is 2 pi. And I'll show you how to find this algebraically in a moment. Period's 2 pi. So if I change b to 2, notice how long does it take to do one complete cycle now? Now, this curve in red It starts at 0, does its maximum, 0, its minimum, back to 0 in half the time. In other words, it takes the normal sine curve is twice as long now as the new one, as sine 2x. The period now is smaller. The period's pi. How long does it take for this graph to do one complete cycle? So where you're going to repeat again. Here is where it starts to repeat. Here you're going up to the maximum again. It takes pi. Now the period is now pi. So it shrunk. Okay. So that's what the b term does. The b term makes it grow or shrink based on what you're looking at. Now let's say it's 1/2. Period is 1/2. Now, if you notice now the red curve, the broken line, is twice as long. One full cycle is twice as long as it normally should be. See, normally, here's your maximum, minimum, 0, minimum, and then at 2 pi, it starts over. Well, now the red curve starts at 0. It hits its maximum here at 5 pi over 6. Oh, no, 0.5, there it is, 0.5. Oh boy, gotta do this over again. Okay, so there's our black points right there, the ones for the black curve. All right, that's one full cycle. Starting at 0 now, the red curve. This is now x over 2 because it's 1/2, x over 2. So x divided by 2. Now what we do is we take the normal period and we multiply it by 2 because it gets doubled. So what's going to happen, you're going to see is our normal curve. Red one starts at 0, hits a maximum at pi, 0 at 2 pi. And notice that that's half the curve. That's half because it still has to go down to the minimum. So that's only the upper half. And the black curve, the original sine of x, does one full period inside that space. So as I keep going with the red one, it hits the minimum at 3 pi. And at 4 pi, now it's about to start over again. So this is now twice as long as it normally was. The period changed. Okay, so when we're looking at x over 2, what we're doing is we're taking 2 pi and we're multiplying that. That's x over 2. 1/2 is x over 2. So you take 2 pi, which is normal, and you multiply that by 2, and now it becomes 4 pi. If it was x over 4, that would be 0.25. Let's see if we can do that real quick. Let me change this to actually, let's go back to 0 first. Go back to 0. And I want to change by quarters. So I want to go by quarters, 1/4. So now this is 1/4. Negative 1/4. Let's go positive 1/4. Here's positive 1/4. So now this is x over 4. So what it looks like is this. It looks like y equals sine of x divided, not that. That's not quite it. We'll put parentheses. X divided by 4. You see how that purple curve went right on top of the red one? That's because it's the same one. It's the same curve. So that's x over 4. So if the period is normally 2 pi, and now I'm dividing by 4, think about now, the opposite of division is multiplication. So multiply by 4. 2 pi multiplied by 4 is 8 pi. So one full period should be 8 pi. Let's take a look. 0, 2 pi, 4 pi is back to 0. The minimum is here at 6 pi, And there it is at 8 pi. Now it starts to do the full cycle again. All right. So you can see, let me get rid of this. As I play with the b term, it makes the curve shrink or grow lengthwise. Okay. Shrink or grow lengthwise. Now, do the negative values affect it? Yes, they do. We're not going to worry about this year. What the negative values do is, think about the way you normally write a sentence. As you write a sentence, you write from left to right. Well, if there's a negative value like negative 2.5, when you write your sentence this time, you're going to go from right to left. So the curve goes the other way. It's really difficult to tell because of the nature of the sine curve. The nature of the sine curve go back to 1 is right there. See, from here, go up. It just keeps on repeating. It keeps on repeating. But here's the thing. If b was negative 1, negative 1, does that look similar? That looks a lot like a negative amplitude, doesn't it? If a is negative 1, the curve goes down first instead of going upwards. And that's something we would use when we get to trigonometry next year. When you start studying trigonometry, we'll start looking at even and odd functions. Sine is an odd function. And what you can do is, instead of graphing sine of negative x, you could graph the opposite of sine x. You could put a negative in front and it'd be the same picture. See, it'll be the same picture. If you have a negative on the inside, what it means is you start by going to the left. You go up to the maximum first, going left this way. But if a was negative in front, the amplitude, you go down first. Going to the right, you go down first. Okay, we're not going to mess with that this year. This year, we're going to make sure that the coefficient in front of x is positive. And we're just going to go this way. We're going to shrink it, or we're going to make it stretch. That's how we're going to play with it. Those are the only two ways we're going to look at these curves this year, because we're making modifications due to the distance learning. This is very difficult to do on your own at home. So we're cutting it down to just the essentials right now, just amplitude, period. We're going to deal with some other things later, like, for example, phase shift. Phase shift is, notice now, here's the C term. The phase shift is when you start to shift the entire curve. Now we're not playing around with stretching it anymore. We're not stretching it horizontally or vertically. We're making that whole thing move. So what that means is, instead of starting at 0 like you normally would, maybe you start somewhere else. So maybe you'd move to the right, you start at pi over 2 or something like that. So this will make you, the phase shift basically tells you where the new curve starts and stops. Okay. So let's go back here and talk about phase shift. Phase shift is where the first cycle begins. So it means the curve shifts to the left or right. Initial interval. This first full period right here, this is the initial interval. So the initial interval is where that first cycle, that first full period starts and stops. Tells you your starting point and stopping point of the first full period. So initial interval is where the first full period starts and stops. In this case here, from 0 to 2 pi. Starts at 0, ends at 2 pi, and then it starts to repeat. That's the initial interval. Okay. All right. So how do we find this information? Well, we're looking at 4 of our basic trig functions here. Sine, cosine, cosecant, and secant. Tangent and cotangent don't really fit into this. They're a little bit different, so they're not quite the same. So how do you find amplitude? Very simple. Amplitude is the absolute value of A. Because what does amplitude tells you? Amplitude tells you how high or low the curve goes. So what we care about there is the actual number, 5. So we go up to a maximum of 5, down to a minimum of -5. Then if it was negative, that just tells you where to go first. Do you go upwards first or do you go downwards first? But the value is what tells you how high or how low you go. Period. Now, the period of any one of these normal curves is 2 pi. That's the normal period, 2 pi. To find the period of any other curve, the period of a curve is the absolute value, or 2 pi over the absolute value of b. Because we really don't care whether b is positive or negative, because all that's going to do is tell us go to the left first or go to the right first. What we care about is the size of that number, that value. So and what we're going to do to it. So if, and again, look at the way it's written. If, for example, we had that other problem, let's say y equals sine 2x. Okay, well, b is 2. What does this say? This says multiplication. So what's the opposite of multiplication? Division. So we're dividing by 2. And then I would get 2 pi divided by 2, the absolute value of 2. That's just pi. So the period is half as big as it normally would be. On the other hand, the other way, if this was x over 2, that's also division, but this is going to be 2 pi divided by 1/2, right? Because b is 1/2. Whenever you see this, x over 2, that is 1/2 x. Any fraction. If x is over any number, split it apart. Put x off to the side. So it's pi over 2 divided by 1/2, which becomes multiplication. So this becomes 2 pi times 2 over 1, or 4 pi. Now it's twice as big as it normally would be. Okay. All right. So that's how we find amplitude. That's how we find period. Phase shift. Phase shift. Does this thing start at 0 or does it start someplace else? For the phase shift, you take what's inside the parentheses, set it equal to 0, and solve. So take what's inside parentheses, bx plus c, set that equal to 0, and solve it. So I'm going to subtract c to both sides. and bx is equal to negative c. Divide both sides by b, and x is negative c over b. So that's how you're going to find our phase shift. Take whatever's inside the parentheses, set it equal to 0, and solve it. If there are no parentheses, this is important. If you're looking at this, y equals 2 times the sine of 3x plus 4. This 4 is not c. This 4 is a d value. All right. So if there's no parentheses, they didn't forget it. It's not there for a reason. It doesn't belong there. Okay. Now sometimes they'll fix this so you don't make a mistake. They'll put the 4 in front. So what they'll do is they'll make it look like this. Sometimes they'll go with y equals 4 plus 2 sine 3x. That way you don't make a mistake and think the 4 is in parentheses. Okay, they'll do that sometimes. The initial interval. So where does the first full cycle start and stop? For the initial interval, you take what's inside the sine, the trig function. Take what's inside. Take bx plus c. Oh, forgot the plus. I'm trying to save space here. Take bx plus c. And you're going to set that between, in a compound inequality, set it between 0 and 2 pi. And you're going to solve that compound inequality. See, what this says right now is this curve starts at 0 and ends at 2 pi. So when you start solving the compound inequality, this is going to tell you where the curve starts and where the curve ends. That's exactly what this is going to tell you. See, when you're done, it's going to look like this. Some number is less than or equal to x, less than or equal to another number. You're going to have 2 numbers on the end. And these numbers here those numbers tell where the first curve starts and ends. Where does that first curve begin and where does it end? Okay. Now, one thing we haven't found out is how do you find the midline? Okay, we're not going to deal with the midline when we graph this year, but next year you will. The midline is back here, D. This is the midline. That is a vertical shift. That means the entire graph would shift up or the entire graph would shift down based on whatever that midline is. Okay, here's some examples. And this is what we're going to be looking at for our first homework assignment. We'll be graphing later. For right now, tonight, all we're going to do right now is find amplitude, period, phase shift, and initial interval. So amplitude, period, phase shift, and the initial interval, bx plus c, 0 less than or equal to bx plus c less than or equal to 2 pi. So that's how we find those values. All right. So the amplitude of problem A, if we look at the leading coefficient, is 3. The absolute value of A. That's simple. Remember, here's A, bx plus c, and d. Period. What is the period? Okay, the number in front of x is 4 pi. So the period is 2 pi divided by the absolute value of 4 pi. Well, 2 pi divided by 4 pi is, the pi's reduce, 2 over 4, which is 1/2. So the period of this curve is 1/2. Phase shift. Now here's a real simple way to determine if there is a phase shift in the first place. The C term. If there is no C term, then there is no phase shift. Okay. Let me go back to Desmos real quick and show you that. Okay, here's Desmos. Here's the C term. And as I was playing with the C term, you saw it started someplace else. So that whole curve moved and started someplace else. Let me see, where are we? Oh, we haven't shown it yet. Okay. So here's our C term. And as I played with that value, that whole curve shifted on the x-axis. The whole thing shifted left or right. Well, if I go to one of my other graphs, notice here bx, the C is missing. Now as I play with B, all that curve does is stretch. It stretches or shrinks. That's it. It's starting at the same point. It does not shift left or right. It just stretches or shrinks. So there is no phase shift. If the C term is missing, there's no phase shift because C is 0. And if you try to do it, you take 4 pi x, set it equal to 0, because the way you determine if there's a phase shift or not is you take bx plus c and set it equal to 0, and you solve that. Well, there's no C term, so that is 0. So if you divide both sides by 4 pi, you get 0. So phase shift, none. There is no phase shift. Okay, initial interval. All right, for the initial interval, I'm going to do this one in green because this one's going to be a little bit more work. I'm going to take 4 pi x and set it between 0 and 2 pi. And what I'm going to do is I'm going to go ahead and divide both sides now, or divide all sides by 4 pi. Because the whole point is I want to isolate that x. I want to get the x by itself. 0 divided by 4 pi is 0. 4 pi divided by 4 pi, those reduce. That's just 1. That's x. And the pi is reduced. That's 2 over 4, which is 1/2. So the initial interval is 0 less than or equal to x less than or equal to 1/2. Now I want you to think about this for a second. If there is no period, if there's no phase shift, does it make sense? If there's no phase shift, does it make sense the curve would start at 0? Yes, that makes sense. Because the phase shift tells you where to start. If there is no phase shift, then you start at 0. If the period is pi, then it takes, the length of time it takes to do one complete cycle is 1/2. So if there is no phase shift and the period is 1/2, that's where your initial interval should be. The initial interval has kind of a built-in check system, and if you're doing these problems on your own, that's what you would use to see if you were doing these correctly. Okay, the amplitude for problem B. The amplitude is the absolute value of A. So A in this case is -2, which means the amplitude of problem B is 2. Period. Okay, now notice this time, here's x. So the B term is -1/2. This is 2 pi divided by the absolute value of B. So for period, I'm going to have 2 pi divided by -1/2. And I'm writing it this way because I would much rather do that than this. That's absolute value. I don't like compound fractions. So I wrote it this way. 2 pi divided by the absolute value of negative 1/2. So this becomes 2 pi times 2 over 1. The absolute value of negative 1/2 is positive 1/2. It's just 1/2. So the reciprocal, multiplying the reciprocal, is 2. So 2 pi times 2 is 4 pi. Period is 4 pi. Phase shift. Is there a phase shift? Yes. There is a C term, so there is a phase shift. So for the phase shift, I'll take Bx plus C, set that equal to 0, and solve it. Let me just kind of do that. Okay, pi minus x over 2 equals 0. Now I want to solve this. So I'm going to subtract pi to both sides. Negative x over 2 equals negative pi. Now I'm going to multiply both sides by negative 2. Negative 2, negative 2. So the 2's reduce. A negative times a negative is positive x. Negative 2 times negative pi is 2 pi. So my phase shift is 2 pi. Okay. Now let's think about this. Initial interval is 2 pi. Period's 4 pi. So let's think about where we're going to wind up. Okay. Initial interval. Going to take pi minus x over 2, set that between 0 and 2 pi. Now this can get rather messy. So if you're worried about this, get rid of the fractions right away. Multiply everything by 2. So let's multiply it all by 2 right now. 2. So if I multiply by 2, I get 0 less than or equal to 2 pi minus x less than or equal to 4 pi. See, the 2 was distributed to both of these. So that's why this is 2 pi, and that's just now minus x. Now I'm going to subtract 2 pi to all 3 parts. Negative 2 pi is less than or equal to negative x less than or equal to 2 pi. And if I divide it all by negative 1, I get 2 pi greater than or equal to x greater than or equal to negative 2 pi. So if you remember, this needs to be rearranged so that the smaller number comes first. So negative 2 pi, positive 2 pi, x. And this thing between the x and negative, it opens to the x. So let's make sure it opens to the x. There's my initial interval. Negative 2 pi less than or equal to x less than or equal to positive 2 pi. Okay. Now, how far is it from negative 2 pi to positive 2 pi on the circle, on the graph? Think about that. It's just like these curves, these graphs are on an x and y axis. So if you remember, on an x and y axis, you've got 1, you've got 2, you've got 3. And on this side is a reflection, negative 1, negative 2, negative 3. Just on this side is the opposite numbers. So the same thing is going to happen for these, but in this case it would be pi, 2 pi, 3 pi, negative 2 pi, negative 3 pi. So how far is it between negative 2 pi and positive 2 pi? That's 1, 2, 3, 4 pi. That's how far it is between negative 2 pi and positive 2 pi. Well, that's the period, 4 pi. Okay. Now, if you're noticing, originally, this says go from 2 pi to negative 2 pi. That means you go left, which, like I said, is what you would normally do when there was a negative in front of the x. You would go to the left. We're not going to worry about that right now, but that's an explanation as to why that number switched. Okay, we've got two more samples. I need the amplitude of problem C here. That is the absolute value of A. So the amplitude of -3, absolute value of -3 is 3. Period. The period is 2 pi divided by the absolute value B once again. So the period, in this case, B is -3. So it's 2 pi divided by the absolute value of -3. That is 2 pi over 3. There's the period. So this thing will do one complete cycle in 2 pi over 3 radians, 120 degrees. It will do one complete cycle. Phase shift. Is there a phase shift? Is there a C term? Yes, there is a C term. So there must be a phase shift. Okay, phase shift. So we're going to take Bx plus C. We're going to take what it says right here inside the cosecant function, pi minus 3x, set that equal to 0, and we're going to solve it. So we're going to subtract pi. -3x equals -pi. Then we'll divide everything by -3. And x is pi over 3. So there's my phase shift. Pi over 3. Okay, now I need my initial interval. My initial interval, let's see what happens. I'm going to take pi minus 3x and set that between 0 and 2 pi. No fractions to worry about here. So I'm going to go ahead now and subtract everything, subtract pi to all three parts. Okay, subtracting pi, I have -pi less than or equal to -3x less than or equal to pi. Let me add a little piece of paper on here so I have some space to work. Now I need to divide everything by -3. So this becomes pi over 3 is less than or is greater than or equal to x, greater than or equal to -pi over 3. And again, this needs to be rearranged so that the smaller number comes first. -pi over 3 less than or equal to x, less than or equal to +pi over 3. -pi over 3, think about that. Here is, right here is -pi over 3. This is +pi over 3. This is 60 degrees going this way, 60 degrees going the other way. That's 120 degrees total, which is what we needed. So my initial interval is -pi over 3 less than or equal to x, less than or equal to pi over 3. The initial interval is the more complicated part to find, but as you see, once you start getting these, graphing these, it actually serves a pretty good purpose. It's pretty easy for some of them. Some of them it's difficult, but the majority of these, it'll be a little bit easier. Okay. I had to use up some of this space, so let me grab another Post-it. All right. What is the amplitude of this problem? You should be thinking to yourself right now, 1/4, the absolute value of A. Okay, period. The period is 2 pi divided by 2/3. or the absolute value 2/3, which is just 2/3. So the period is 2 pi times 3/2. The 2's reduce, so I have pi times 3, which is 3 pi. There's the period, 3 pi. Phase shift. Okay, for my phase shift, I'm going to take 2x/3 plus 2 pi, set that equal to 0, and solve it. So if I subtract 2 pi to both sides, 2x/3 equals negative 2 pi. Now if I multiply both sides by 3/2, 3/2, these reduce. X is equal to a negative, that reduces, 3 pi. Okay, my phase shift is negative 3 pi. My initial interval is going to be negative 3 pi less than or equal to x less than or equal to 0. There's my initial interval. All right. Now, you might be wondering how I know this. There's 2 reasons I know this. It doesn't apply to all of these though, so you have to be very careful with this. Well, first, let me do my initial interval. Initial interval. All right, I am taking 2x/3 plus 2 pi and setting that between 0 and 2 pi. Now, once again, I don't like fractions. I don't want to deal with fractions. I don't want to mess with them. So let's go ahead and multiply everything by 3 right now. I'm going to distribute 3 in here, and I'm going to multiply by 3 over here. That gives me 0 less than or equal to 2x plus 6 pi less than or equal to 6 pi. No more fractions. This is exactly what I wanted. No fractions. Okay, now subtracting 6 pi. And now I have negative 6 pi is less than or equal to 2x less than or equal to 0. Now if I divide everything by 2, negative 3 pi less than or equal to x less than or equal to 0. That was my initial interval. Okay. Now how did I know that? Okay. It's a little tricky. This only applies to letters D and A. This is the only thing it applies to. It does not apply to B and C. The reason it doesn't apply to these two is because right here, negative x, negative 3x. That's why it doesn't apply to those two. But it works for this one, for these two. When the x term is positive, the phase shift will always match the first part of the initial interval. So if there was no phase shift, that means you start at 0. Here, my phase shift was at negative 3 pi. You start at negative 3 pi. Okay? Now, how do you get the second number? Well, if the period is pi is 1/2 and you start at 0, add 1/2 to 0. 1/2. If the period is 3 pi and you start at negative 3 pi, add 3 pi to negative 3 pi, you're at 0. That's how that works. The reason it doesn't work for these is because you graph that way, going from right to left. That's why it's not going to work out. So that little shortcut deal there, that won't work out for that. It goes that way. All right, so that first assignment you have tonight is I'm going to give you some functions, and you're just going to find the amplitude, the period, the phase shift, and the initial interval. There is no graphing involved. You're just finding those 4 values for the assignment tonight. We will start graphing at a later time. Okay. And always remember, what are these values? What do they mean? Amplitude. How high and how low does that curve go? That curve goes up here. This went to this value and to this value. Can you tell me what the amplitude of this curve is? 3. So yeah, I'm looking at 3 sine. All right, what's the period? 2 pi. The period is 2 pi. Is there anything in front of x? No, not if the period is 2 pi, so that's x. This is the curve for y equals 3 sine x. It started at 0, so there's no c term, and it didn't. The whole graph didn't shift up or below. The midline is at 0, so the term at the back is 0 as well. Okay, so remember the vocabulary here. Amplitude, how high and how low the curve goes to its maximum and to its minimum. It's going to oscillate about the midline. The midline. Period. How long does it take to do one complete cycle? How do you recognize one complete cycle? Because once you hit a certain point, the curve starts to repeat itself. Okay, at that point, that's one complete cycle. Then it starts to repeat. Phase shift. Does the graph slide to the left or to the right? So it's a transformation left or right. That's all it does is tell you where it starts. The initial interval tells you where the first point and the last point are of the initial interval. That first full cycle, where does it start and stop? And the midline is responsible for a vertical shift in the function. The midline is simply, if there is a d value, that whole graph would shift up and you'd oscillate about that line. You'd go, whatever the amplitude is. Let's say, for example, I gave you y equaled 4 sine x plus 2. 4 sine x plus 2. So this is really rough here. What would happen is, okay, 1, 2, 3, 4. What would happen is you'd go up 2. This would be your midline. So 1, 2. Here's the midline. And then we would have an amplitude of 4. So from 2, you'd go up 4 spaces. 1, 2, 3, 4. You'd go all the way up here to 6, and then you go down 4 spaces. 1, 2, 3, 4. Down to -2. And you would draw your curve here in between these values here. Now notice what I'm doing here is I'm drawing these broken lines because I don't know about you, but whenever I try to write a paragraph on paper that's not lined, my sentences tend to slant and tilt. So these lines are going to keep me honest. It's going to keep me straight. So as I start here for the sine, I would go up to a maximum of 6, down to that 0, to the minimum of -2, back, and then the curve would just keep on going. It would oscillate in that manner. Okay, and you notice with those broken lines, I know exactly where to start and where to stop. If I didn't have those, I would probably have really tall curves on one side and really short ones on the other side. It just wouldn't look right. And what you have to do here is, this is what we'll do next year. At your maximum, when we have vertical shifts, you need to associate that with a point on the x-axis. This interception with the midline gets associated to the x-axis, the minimum to the x-axis, the midline here to the x-axis, and so forth. So maximums, zeros, minimums. And in this case, the 0 means where does it hit the midline? That's a 0. And then you'd find those values. And since the period is just 2 pi, you'd know those values. Those values would be pi over 2, pi, 3 pi over 2, 2 pi. Then it starts to repeat and so forth. But that's how you use the midline and amplitude. Okay. No graphing tonight. Just find those amplitude, period, phase shift, and interval. All right. Good luck on the assignment. Next time, we'll start graphing trig functions. See you then.